Okay, I don't normally like to do homework problems in videos, but I found this one to be kind of hard. So I thought I'd go through this one. I guess you still have to write it out. Um, so they told us this is 55, and they told us the values of R1, R2, C1, and C2. And so I think this is one of those cascading, maybe since they're, I don't know, 2 op amps in a row. Maybe not. So we're just asked to find the transfer function, and with op amps, I always use nodal. So I was trying to identify, at first I just gave basically every node a label. You can see as you go from left to right, I've got my V1, V2, V3. And this time, unfortunately, the positive terminal doesn't go straight to ground in either of them, so we don't get 0 like in some other problems. But I do still know that the voltages are equal at the positive and negative terminals. So if I call it V1 on the left, then at the negative terminal, it's also V1. And even though I called this node V2, I realized, well, if you follow it back to the negative terminal, there's no circuit element there. So really, V1 is equal to V2. And then V3 is the next one, and that's the voltage at the positive terminal of that op amp. So that has to also be the voltage at the negative terminal of that op amp. And then when I follow that around, I get to this node right here, but there's no circuit element. So V3 and V0 are the same as well. So that reduces your number of variables. So if V1 is equal to V2 and V3 is equal to V0, we really just have, I guess, 2 unknown voltages aside from the Vin. Okay, so I used nodal analysis for those 2 equations. It's relatively easy to get those 2 equations. I don't know if it's easier to plug in the values right away or leave variables until the very end and then plug in. This time I plugged them in right away. And again, instead of dividing by a fraction, I multiply by its reciprocal. So that V1 minus V0 was multiplied by S times that. And then I just multiplied first by 2,000 to clear fractions. And then I guess I didn't want to deal with negative exponents, so I multiplied everything by 10 to the 5th as well. And then I grouped the V1 terms together, and there was a V in and a V out. Yeah. Okay. The reason I paused is I was like, how did I get 10 to the 5th times or plus 2s? I was looking at these being multiplied together, but that's 10 to the negative 5th. So the 10 to the 5th canceled that out. So I just thought the way I have equation 1 written, it looked a little bit nicer and easier to deal with. Okay, and then at the other node, the V3, there were only 2 non-zero currents, so we just have 2 terms in that equation. And again, instead of dividing by a fraction, I multiply by its reciprocal. And then again, I didn't want to deal with negative exponents, so I multiply by 10 to the 8th, and 2,000 goes into 10 to the 8th 50,000 times. So that multiplying by 10 to the 8th got rid of the fractions as well. And so then I factored out the V0 and moved this V1 over to the other side. And so then I could solve for V1 in terms of V0, because remember, we just want the relationship between V in and V out. We don't want the V1 in there. So in my equation 1, where I had a V1, I want to replace, if I can, replace it with something in terms of V naught, and then that equation 1 will only have V out and V in it. Okay, so I just divided both sides by what V1 was being multiplied by. And then I said, that's my equation 2, and I subbed that in for the V1 in equation 1, which was right at the very beginning. And so then equation 1 becomes this. So I just rewrote it. There's still a V in after it and a V out after it. But I multiplied, simplified a little bit there. And then when I canceled that factor of 2 and think of this as being over 1, then I have 2 factors of 50,000 plus s in the numerator. So I just wrote that as 50,000 plus s squared, still over 25,000, and then minus the 2s from the term at the end, and move the v in over to the right-hand side of the equation. And then I remember we want v out over v in equals something. So I'm going to divide both sides by v in, and then I have to multiply both sides by the reciprocal of what I'm multiplying by, or divide, but it's a lot. I think it's easier to multiply by a reciprocal, so I got a common denominator. So I just had to multiply the minus 2s times the 25,000, and I multiplied out in that 50,000 plus s squared. And then I combined the 2 terms with s, because this 10 to the 5th is 100,000 minus 50,000 is 50,000. So I kind of did it in one step. So I combined those terms and multiplied by the reciprocal in one step. So I divided by v in, multiplied by the reciprocal of this, but I combined those 2 terms to get plus 50,000. And so there you see that's my new denominator. And the 25,000, when I multiplied by the reciprocal, got moved up in the numerator. Okay, and then I just 25,000 times 10 to the 5th is the same as 25 times 10 to the 8th, left the denominator like it is. That's my transfer function. And now it's the same as all the other problems. You take the square root of the constant at the end, that's your omega naught, set the middle term equal to omega naught over q, and you can solve for q. And then you don't even need any of that to know whether what type of filter it is. You just see that the numerator is a constant. And so when you plug in 0 for s, you get 1. And when you let s go to infinity, you get 0. So it's a low pass filter.